Hello and welcome to this review video of Improving Quadrilaterals. In your Unit 6 review packet that you've been provided, there is an example problem for proving quadrilaterals. We are given the points -2, 1, -6, 1, -6, 5, and -2, 5. So the first thing we're going to want to do is to set up the chart that we've been using when we have been proving these quadrilaterals. Remember, you want the sides going down the left side, and we want the distances in the middle and the slopes on the right. Now, yours doesn't have to be this large. I just made it a little bit larger so that we could see what I'm writing in the boxes. I know one of the complaints before has been that we've written too small. So the first thing we need to do is find the distance and the slope for each line segment. So for AB, we're using the points -2, 1, and -6, 1. So we need to plug these into our distance formula first. So we're going to have the square root of -6 minus a -2 plus 1 minus 1 squared. I need my square over here as well. Now remember, a minus becomes a positive. So this is really -6 plus 2 squared plus 1 minus 1 squared. If we simplify within here, we get -4 squared plus 0 squared. Now, anytime we square something, even though that's a -4, squaring something means multiplying it by itself. So if we multiply a negative times a negative, we're going to get a positive. Anytime you square something, you're going to get a positive number. So we end up with 16 plus 0, which is the same thing as the square root of 16, which simplifies pretty nicely down to 4. Now if we do slope, remember it's y2 minus y1 over x2 minus x1. So I'm going to have 1 minus 1 over -6 minus a -2. Again, we have to deal with that negative. So 1 minus 1 is 0, and -6 plus 2 is a -4. But 0 divided by -4 is 0. So go ahead and pause the video and go ahead and figure out the distance and the slope for the remaining sides. Alright, now that you've had a chance to go through that, I'm going to go ahead and show you what the distance and slopes are rather than working them all out again for you. And feel free to pause at any point if you need to zoom closer in on any of this. For side BC, we're going to get a distance of 4, and we're going to have an undefined slope. Remember, anytime we have a 0 in the denominator, our slope is going to be undefined. For CD, we're also going to have a distance of 4 and a slope of 0. And for AD, we're going to have a distance of 4 and an undefined slope. So now what we have to do is we have to analyze what we've gotten and be able to interpret which type of quadrilateral this is. So I need to look at a few different things. First, I want to look at, do I have any parallel sides? Okay, remember parallel sides are going to have the same slope. So I have two pairs that have the same slope. I have my set that has 0 and my set that's undefined. So AB, and I'll come down here and write to the bottom, AB is parallel to CD, and BC is parallel to AD. So I have two pair of parallel sides. Now I also have to look at perpendicular sides. Perpendicular have negative reciprocal slopes or opposite reciprocal slopes. Now, this is one that's a little bit tricky. A lot of times people don't realize that 0 and undefined are reciprocals of each other and that they form perpendicular lines. But if you remember, anytime that you have a 0 slope, you're going to have a horizontal line. Anytime you have an undefined slope, you're going to have a vertical line. A vertical line and a horizontal line will always be perpendicular to each other. So I'm going to see that AB is perpendicular to BC, and I'm going to have CD perpendicular to AD. Now AB is also going to be perpendicular to AD, and BC AC is also going to be perpendicular to CD. So I'm going to find that I have 4 perpendicular sides, which means I have 4 right angles. Now the last thing that I need to do is look at my sides. Do I have any congruent sides? In this case, if I look through, every distance was 4. So that means I have 4 congruent sides. So when we put all that together, our only shape that has 4 congruent sides, 4 right angles, and 2 pair of parallel sides is a square. So we would prove that this is a square. We know it's not a rectangle because all 4 sides are perpendicular. It is a rectangle, but that's not the most specific name we can give it. The most specific name we can go square. The same thing that distinguishes it from a square and a rhombus, we have the 4 right angles. Even though it is a rhombus, we identify it more clearly as a square since we have the more specific information. And we know it's not a trapezoid because we have the parallel sides. We have 2 pair of parallel sides where a trapezoid only has 1. And similarly, a kite doesn't have any, so we know it's not a kite as well. So we go through, we analyze, just to recap. We need to look at parallel sides, we need to look at whether we have right angles, and we need to look at congruent sides. By combining those 3 factors, we can figure out what shape we have. Hope this was helpful.